Hello dear students, I welcome you to NEET World. So in this session, we will be discussing CUET 2024 question paper, CUET UG, okay. The question paper of chemistry subject we will be discussing in this session, okay. So this session will be highly helpful for those who are going to attempt CUET 2025, I mean in this academic year and also in the upcoming 2026 also, okay. So do watch it completely, and if you have any difficulties during the discussion, so you can write in the comment box, we will be sorting out, okay. So you can also involve in the session very nicely by writing in the comment box whatever you feel, whatever the difficulties you are feeling, whatever the doubts you have, write in the comment box. We will be looking into it and we will be clarifying and rectifying everything, okay. So if you are started watching this, just click on the like button first and we can proceed with the content, okay. So subject chemistry and code is this one, and it is an English medium paper. So time allowed is 60 minutes, maximum marks 200, total questions are 50, okay. Number of questions to be answered, those are 40 here as per the question. So these are the information given here about the CUET exam instructions, okay. Then let us start our discussion, and here we have question number 1. Here we have question number 1, the total number of ions produced from the complex. So this is a complex they have given. So this is a complex they have given, Cr, NH3 6 times and Cl3. So how can we write this? So let me zoom it out, okay. So now this is the complex they mentioned. So hexachromium complex, hexaamine chromium complex here. So now whenever we are keeping this kind of complexes in the aqueous medium, whenever we are placing a complex in aqueous medium, so it will get ionizes. So how it will get ionizes? So complete species which is inside the coordination sphere remains like that. The coordination sphere will not lose its identity even after keeping in the aqueous medium, okay. So this complex will be stays as a 1 ion with +3 charge and 3 chloride ions, 3 Cl minus ions. So total number of ions, how many are there? So this is 1 and these are 3. So total 4 ions are there. How many ions? 4. So that's it. So we have option number 3, that is 4 ions. I hope that is clear, right? I hope there is no confusion, right? So I will be giving one more question to you, so you can look into it. So here I mentioned, like if there is a metal M having complex with ligands, let us say one complex itself will be taking, so nickel, Cl4 I am writing, and here I am writing Na2, okay. So now tell me number of ions formed when this is placed in the aqueous medium. Now tell me how many ions will be obtained from this. You can just have a look into it. I just given it as a homework question based on the first question, okay. Now look into this question. Arrange the following in the decreasing order of number of molecules contained in it. So we have O2 molecule, CO2 molecule, CO molecule and H2 molecule. So which is having maximum number of molecules. So how can we find the number of moles first? How many moles in 16 grams of H2? How many moles it is? Number of moles equals to given weight by its molecular weight. It's a gram molecular weight you can write. What is the given weight? 16, right? 16 grams. And molecular weight for this H2 is 2 gram per mole, gram molecular weight or molar mass. Therefore we are getting 8 mole, okay. So 8 moles of H2 is there. So we can also write it as 8 into 1 mole contains Avogadro number of particles, so 8 Na. So like this if you do, so for this you will get 8 Na, and for this you will be getting 16 by 32, molar mass is 32. So this is 1 by 2 Na, so which means this is having 0.5 molar 5 into Avogadro number of molecules of CO2, I mean O2, and from this 16 by 44 you can get, 16 by 44 you can get. First one is 16 by 32, second one is 16 by 44, and third one is 16 by how many? 16 by 12 plus 16. So 12 plus 16. So you can take 28, okay, like this. And the last one is 16 by 2. So this is a big number now. This is 8 into Na, Avogadro number, 8 into Na times. So this many number of molecules are there. So it means D is having maximum, decreasing order they are saying now. So maximum is for D and then next, so which is the like large number here. So this is the large number. So D, C I am writing, and the next A, and least is this one, B. So where do we have this kind of option? So highest decreasing order they are saying now. So decreasing order means highest first, D, C, A, B. So option 2 we have D, C, A, B, so you can choose that. I hope this is also clear now, there is no confusion, very simple mole concept question. Okay. So here we have dissociation and association type of question. From where do we study this? This will be studying in solutions chapter. Where we will be seeing this? We will be seeing this in solutions chapter. So what it is saying here? So whenever we have a molecules, like n number of molecules are there, these are undergoing association. It means n will become associate each other and becomes like this. Okay. So now initially how many we have? We have n number of particles. Initially this reactant particles. After some time what happens? So this n will be associating, like it will be like this, you should write. Okay. This alpha represents degree of association. Okay. So this many number of particles are formed here. So now what I am doing is I am dividing both sides with n. Okay. So if we do that, so what we will be getting? So this is 1 minus alpha we will be getting here, and here we will be getting, sorry, here this is just 1 alpha. Why I am writing 1 alpha here? See, whenever we have a coefficient n here, so that many number of particles are removed from here. That's why I am writing it as n minus n alpha. Here we are getting 1 particle, so 1 alpha I have written. So I am completely dividing with n, therefore it will remains as 1 minus alpha. Here n alpha by n. I hope this is clear. So now total number of particles are how many? Total number of particles are, add these total numbers. So 1 minus alpha plus alpha by n. So this is the total number of particles. Now Van 't Hoff factor I is given as total number of particles after association or dissociation by initial number of particles you should take, like this. So this is the remaining thing we are having. So now I can also write this I equals to 1 plus 1 by n minus 1 alpha. So why I am writing like this? So 1 by n minus 1 alpha is taken as common here. I hope this is clear. Okay, now look into the question here once again. So what they have given? So for the given substance, Van 't Hoff factor is found to be 0.8. Okay, and 1 plus 1 by n. N value is how much they mentioned? So we need to find value of n only. Okay, minus 1. What is the alpha? They mentioned fraction of associated molecules was 0.3. So alpha is 0.3. Done. We are done with the question. See, so if I if I send this 1 here, so it will become 1 minus 1 plus 0.8, that will be minus 0.2, okay, which is equals to 1 by n minus 1 into 0.3. Okay. So now I am removing this and these decimals. So I am writing minus 2 by 3 equals to 1 by n minus 1. So I hope there is no confusion till here. Okay. So let us move little more for simplification. So what I can write? 1 by n equals to so 1 minus 2 by 3 I can write, right? Okay. So from this what I can write, just by taking the fractions 3 in the LCM. So now it will become 3 minus 2. 3 minus 2 means 1. Okay. So we got 1 by n equals to 1 by 3. If we compare this and this, so n value will be 3. That's it. This is our final answer. I hope there is no confusion. It is very clear now. So with direct clear cut explanation, everything I have included here, everything is clear, I hope. If there is any confusion, you can write in the comment box. Okay. Next, the oxidation state of cobalt in this complex. See, this is the complex and these are the ionic sphere. So now sulfate ion, each sulfate ion is how much charge? Minus 2. How many are there? 3 are there. So minus 2 into 3, it is minus 6. For this anionic sphere, total charge is minus 6. So this cationic sphere will have total charge as plus 6. Okay, done. So now here inside this coordination sphere we have ethylene diamine, which is a neutral ligand, right? And coordination sphere is of twice. So I can say for cobalt, let us say X. So 2 cobalts are there, so 2x. Again this is neutral, so 0, okay, into 3 equals to plus 6. So therefore X will be plus 3. So what is the oxidation state of cobalt here? That is plus 3. That is what option number 1. So I hope this is also clear, right? There is no confusion. Next, the correct structure of dipeptide. Okay, so in dipeptide, which is formed by glycine and alanine, what is the correct structure they are asking. So for this, we need to know what is the structure here, what is the formula of glycine. So these are alpha amino acids, you can write like this, COOH, this is a carboxylic acid, here I am writing CH, okay, and here alpha carbon, so here you place NH2 group, okay. So now here I am writing NH2, okay. So this is about glycine, here you can write 2 times, okay. This is about glycine. Now what about alanine here? So alanine here I am writing COOH, it is also looks like glycine, just replace hydrogen by methyl group, that's it, okay. Next CH, NH2 and here CH3, that's it, this is the alanine, okay. Now peptide bond is formed by removal of water molecule using this OH and using this hydrogen from the nitrogen, that's it, okay. So I am erasing this first the previous question, therefore we can write here, yes, look here. So by removing this water molecule OH from carboxylic acid, H from nitrogen of this amine group, therefore what we can get, NH2 CH2 CO NH CH2 COOH, okay, this is not CH CH3. So if we look into this, we have option 1 similar to this, NH2 CH2 CO NH CH CH3, this one, and COOH. I hope it is clear. Option number 1 is correct for this question, right? Okay, let's move further. Okay, so look into this once again. I hope everything is clear here, there is nothing confusion in this. So let me check anything is okay. So in this question what we have, copper metal crystallizes into FCC lattice with a unit cell edge length of 361 picometers. The radius of copper atom is. So how can we write this? So FCC lattice means, how do we have FCC means how it will be there. So for a cubic unit cell, if you say, so if we take like this, all the corners are occupied by one atom, okay. So at all the corners there will be one atom, okay, and FCC there will be face centered also. So each atom will be there on one of this face. There are 6 faces, and each face there are one atom on each face. Now you need to understand that. So if you take like this, if you take the same cube in this manner, so now on each face, let us say this is the top face I am taking. So what is the edge length they told? This is A, this is also A, all edge lengths are A. Now I am taking a diagonal like this, okay, face diagonal. So on this face diagonal we have one atom at corner, this corner, and also at this corner, and one is at middle, okay. So now these 3 atoms will be adjacent to each other, they will be like this, okay. So now I am writing, so this distance, which is nothing but for this atom R, for this atom from here to here the radius is R, from here to here 2R, and from here to here this atom there are total 4 R's, 4R equals to, okay. Now use a Pythagoras, like see Pythagoras if you use, so here A I told you, this is what we need to find, 4R. So I can write 4R square equals to A square plus A square, right. So I am writing, this is A, that's why A square plus A square. So 2A square equals to, okay, 2A square equals to 16R square, okay. So now I am writing like this. So I can remove this, I can write it as 8, okay. So R square equals to A square by 8, A square by 8. So now this again I can write in other format also. Now what is the distance, what we need to find? Radius of copper. So radius equals to radius equals to r square. I am sending this r square to that side, so it will become a by, okay, 2 root 2. What we will get? A by 2 root 2 is the answer. I hope there is no confusion here. So this square cancel. So when it is 8 square, I can write 2. See, 8 square I can write it as 8 root of 8 I can write, 4 root 2. Yes or no? 2 square means 4, that's why I am writing root 8 as 2 root 2. I hope this is clear. So root 8 I am writing 2 root 2, that's why we got this answer. Okay. So now placing a value. What is the a value here we have given in the question? So they have mentioned it as 361. Okay. So 361 by 2 into what is this value? Root 2, that is 1.414. So by substituting this and cancelling out, so you will be getting around 127 picometers. So what is the answer for this? So first option is the correct for this particular question. Next, 75% of first order reaction gets completed in 32 minutes. So how can we do for 50% completion? T50 is how much they are asking. Okay. So let me erase this first. Okay. So look here, 75% of a first order reaction. So first order reaction, how can we make? So for example, A is the initial concentration during the reaction. So if I say 50% means it should become, concentration becomes A by 2. So this is the T half, the time required to complete the half of the concentration, half of the reaction. Okay, T half, let us say. Now again one more T half means it will become A by 2 by 2. It means A by 4 I can write. Okay, this is second T half. Okay, so now from here to here, can I say from here to here 50? See, A by 2 means 50. If it is 100, this becomes A. If A is 100, this becomes 100 by 2, that is 50. Again 50 by 2, it means this is 25. So for completion, see, now what is the concentration remaining? 25% is remaining. It means 50% is completed. So I can say this is T 75% completion. So T 75% equals to 2 T half we can write. Right now? So 2 T halves we can write. Okay. So now what is the 75% they have given? This is 32. So for T 75, time required for 75% is 32. So they are asking for 2 T half. So T half. Okay. So this will be 16. So T half is how much? So time required for 50% completion of reaction is 16 minutes. So first option is correct. I hope this is also clear now. There is no confusion, I hope. Okay. So if there is anything issue with the discussion, you can write in the comment box. We will be looking into it. Okay. Then next let us move further. Which of the following compounds will be repelled when placed in the external magnetic field? So whenever we place in the external magnetic field, what happens here? Okay. So how can we answer this kind of question? See, if there is a paramagnetic substance, so that will be attracted by the applied external magnetic field. But whenever we have a species which is diamagnetic, if it is diamagnetic, that will be repelled by external magnetic field. So always remember, whenever a diamagnetic substance is placed in the external magnetic field, so it will be repelled in the external magnetic field. That compound will be repelled in the external magnetic field. Now identify which is diamagnetic, which is paramagnetic, that's it. So your answer is done. Okay. So now here copper, which is having +2, it is having D9 configuration. So one odd electron will be there now, so it is paramagnetic. Okay. So now if you look into this, this one and this one, let us see. Okay, here K4FeCN6 we have. Okay, so in this iron is in +2 oxidation state. Iron is in +2 oxidation state. So if it is +2 oxidation state, so Fe +2 I am writing. So this is 3d6 4s0. Okay, so now again what kind of ligand here we have? So the ligand is strong field ligand. What is that? Strong field ligand. Therefore all electrons are lies only in T2g set. So if we say this d orbitals are Eg and T2g set, so how can I write So all the 6 electrons can lies in the EG T2G set itself. There is no electrons in the EG set. So I can say this substance is diamagnetic. What is that? Diamagnetic, which is repelled by external magnetic field. When it comes to this one, so Fe, here it is Fe plus 3. Okay, plus 3 means it is having d5 electronic configuration. One unpaired electron is there, so this is paramagnetic, we can directly say. Okay, so odd number of electrons if we have, then that is paramagnetic. Here even number of electrons and all those electrons are paired up. So then I can say that is a diamagnetic substance that will be repelled by external magnetic field. This is how you have to do the question. Okay, I hope this is clear without any confusions. Okay, let's move for next question. Again, this is also based on magnetic field only, magnetic momentum calculation from coordination chemistry. See, when it comes to chemistry in CUET, so you can expect maximum number of questions from coordination complexes. So you can focus more on coordination complex. Okay. So now look here, the spin only magnetic moment value for hexacyanomanganate 2 ion. So how can we write? Hexacyano, it means cyanides are 6, hexacyanomanganate Mn. Okay, so they are saying it has 2. So manganese oxidation state is 2. It means what is the charge on it? It should be 4. If it is minus 4, I can write. So I can write for manganese X, let us say 6 ligands are there, each one minus 1 charge, overall equals to minus 4. So X will be minus 4 plus 6, it will be plus 2. So this is how you can find the oxidation state. So whatever we represent the complex, it is correct. Now what is the oxidation state we got? Manganese is plus 2. So Mn plus 2. So manganese is having, in atomic state it is having D5S2 configuration, 3D5 4S2. If it is plus 2 configuration, 4S0 you should write. Okay. Now D5 electronic configuration is there. So whenever we have D5 electronic configuration with how many ligands? Hexa ligands. So we know it will be a octahedral complex, but let us see what type of complex is it, inner orbital complex or outer orbital complex. Okay. So I am writing 1, 2, 3, 4. So 5 orbitals are there. Now this is 3D, next is 4s, and the next we have what? Next we have 4p, like this, 4p. Now how many electrons are there? 1, 2, 3, 4, 5. 5 electrons are there. Now after writing this, see, we know cyanide is a strong field ligand, SFL, strong field ligand. So it can pair up these electrons, but after pairing, how many orbitals we required? 6 empty orbitals are required. Here we have 4, but remaining 2 are required. So if we pair up this, so after pairing up, so what do we have? So what do we have if we pair up this? So it will become 2, and this can also pair up. So it will become like this, and we have 1 unpaired electron, okay, in the orbitals. Okay, like this we have, and here 1 empty, here 3 we have like this. Okay, so 1, 2, 3, 4 orbitals are there. Okay, so after pairing these, do we have any unpaired like 2 vacant orbitals are possible? Yes, here we have 4, here we have 2. So total what is the electronic what is the orbitals involved? D2 sp3. So now how many unpaired electrons are there here? 1 unpaired electron is there. So whenever we have n equals to 1, number of unpaired electrons are 1. So you can take magnetic momentum formula root over n into n plus 2 Bohr magnetons, right? Now what is the n value? 1. So 1 plus 2, it is 3. So root 3, it is 1.73. That's it. This is the answer you can go with. Okay. So if it is weak field ligand, no pairing takes place. Like in this case, instead of having cyano, if we have chloro, so that is weak field ligand. So in that case, we have 5 unpaired electrons. So we can get 5.9 as a answer for weak field ligand. Since cyanide is strong field ligand, we'll be getting number of unpaired electrons 1 and magnetic momentum as root 3, that is nothing but 1.73. I hope this is also clear, right? No confusion. One of the important interesting question it is. Okay. Next. the correct order of increasing boiling points in the of the following compounds. So we have pentane 1-ol, N-butane, and the next pentanol, ethoxyethane. Okay. So now in this case, boiling point whenever they ask, so you need to check for its molecular weight as well as intermolecular attractions also. So in this case, alcohols will be always having more intermolecular hydrogen, like intermolecular forces due to hydrogen bonding. Therefore, I can say pentane 1-ol will be having highest boiling point. So here, everything is same. Then next, butane will be having least because it is just a hydrocarbon. So butane. So you can remove these two options. Okay, increasing they are saying na. So next, ethoxyethane, this is ether, this is aldehyde. Now aldehyde will be having more, so that is there only in this option. So this will be the correct. So why aldehyde than the ether? Because of dipole interactions are more in the aldehyde than this ethoxyethane. That's why option 4 is most appropriate answer. Okay. So now look into option number question number 11. So I will be taking some water. Again, next here we have phenol. We have phenol, C6H5OH means it is phenol, okay, treated with zinc dust. So what happens whenever we treat phenol with zinc dust gives benzene ring. So our A is benzene. So upon treating with the CH3Cl and anhydrous AlCl3, that is what Friedel-Crafts alkylation. So our B will be alkylation will be taking place on benzene ring. So this is methyl benzene is our B. Okay. So B upon treating with this thing, okay, so we can expect oxidation. So oxidation, see, all of them having benzoic acid. It means this methyl group will be converted into benzoic acid form, like carboxylic acid, COOH. Okay. Now to this we need to add nitration reaction. I mean we need to do nitration. So where do it happen? This is electron withdrawing group. Therefore it will nitration takes place at a meta position. Okay. So I am writing NO2. Okay. So meta nitrobenzoic acid is the answer. That's it. Very simple, basic question. Okay. Next, golden number range of some lyophilic colloids is given below. Okay, which among these can be used as a better protective colloid? So always remember, so protective colloid, so lesser the gold number, more is its like better it is as a protective colloid. So which is having lower gold number? So here option A is having lower gold number, so that will be a better protective colloid. So you can go with option number 1. That's it. Okay. Next, the reaction of aniline with HNO3 and sulfuric acid will produce 47% of. Remember, so aniline if we take and we are treating this with HNO3 and sulfuric acid. So this is nitration of aniline. Okay, aniline. So now nitration of aniline, during this process, this is acidic medium releases H plus, and aniline is a basic compound. So first of all, so this H plus is taken by this aniline and forms anilinium ion like this. Okay, like this. Now this is a strong electron withdrawing group, whereas NH2 is a strong electron releasing group, but this acts as a strong electron withdrawing group whenever the reaction is taking place in acidic medium. Now if it is strong electron withdrawing group, so this will be nitration takes place at meta position. So what is the product we can get? So one is meta product like this, and the other one is ortho product when it is acting as electron releasing group, and one is para product. Okay, like this. So these are the 3 products possible, but remember 47% is for para product, so you can go with para nitro aniline. Okay, so this is what you need to remember here. Again, there is a major quantity for meta product in this reaction, so you can also remember that thing also. Now, basic nature of amines. So how can we answer this kind of basic nature of amines? So whenever nitrogen, like in amines, if only one alkyl group is present on nitrogen, and then we can say that is as primary. Okay, if two alkyl groups are present, this is secondary. If 3 are present, this is tertiary. Out of these 3, which is more basic is a question here. Okay, so if R group is here it is ethyl group, see ethyl. So if R group is ethyl, okay, always remember 2-degree amine, I mean secondary amine is more basic than tertiary, then primary. This is the order in aqueous medium. In which medium? Aqueous medium. Okay, so basic nature of amines depends upon electron releasing groups. More the number of electron releasing group, more is the basic nature. And one more factor is hydrogen bonding. Okay, when we are taking in aqueous medium, so after accepting the proton, that base will be having hydrogens, right? Hydrogens attached to this nitrogen of this amine. So now that will be stabilized by hydrogen bonding. So what are the two factors? One is plus I groups, higher the more the plus I groups, more is the basic nature of amine, and the next is hydrogen bonding in the aqueous medium. Okay, solvent effect we can say. So by considering two factors, secondary amine is more basic. Okay, and the next out of these two, primary and tertiary is more basic when alkyl groups are ethyl. So this order works only when R is ethyl, when R is ethyl group. I hope this is clear. Okay, now in case of if R is methyl, so what is the order? So if R is methyl, so we will get 2, 1, 3 is the order. So you can remember, you may expect this question in this year exam. Okay, now this is in the aqueous medium. What if it is in the gas phase? If it is in a gas phase, it is always remember 3, 2, 1, because there is no hydrogen bonding in the gas phase, only inductive effect or electron releasing groups will dominate the basic nature. I mean that will be the deciding factor of this basic nature of amines. I hope it is clear. So what is the answer here? So do we have any option from these 3? Okay, so 2 is more, so 2 is more, 2 degrees here, then next 2, 3, 1, 3 is here, 1 is here, and last is aliphatic amine. Always least is aromatic amines. Always remember aromatic amines are less basic than aliphatic amines. So option number 2 is most correct here. Okay, go with that. Next question, which are the following gives HVZ reaction? So HVZ reaction is nothing but, so whenever we have alpha position carbon, hydrogens and alpha position carbon of carboxylic acid, upon treating this with chlorine, okay, so that will be gives alpha halo carboxylic acid. Okay, so what is the criteria? We required one hydrogen at least on the alpha position, that will be converted into halogenation. Okay, alpha chloro carboxylic acid. Okay, so now here there is no alpha position hydrogen, there is no reaction in this. Here also no alpha hydrogen, and here also no alpha hydrogen, only in one it is possible. So one option, first option is correct. Hope it is clear. See, GOC part, they are highly focusing on GOC part and basic reaction mechanisms, right? So basic GOC part, they are highly focusing basic nature, acidic nature, carbocation stability, they will be asking these things. Okay, so you can focus on GOC part more effectively if you are really preparing for CUET. Okay, now arrange the following acids in the increasing order of acidic strength. So which is more acidic? We know nitro group is strong electron withdrawing group, therefore electron withdrawing groups increases acidic nature of carboxylic acids. Okay, increases acidic character of carboxylic acid, and electron releasing groups decreases acidic character of carboxylic acids. Okay, now in the NEET 2025 exam, there is a question on this carboxylic acids acidic nature. Okay, there they given alkyl groups. Alkyl groups are releasing groups, therefore acidic nature decreases when it is having alkyl groups. Here we have nitro group, fluorine, chlorine. So these are minus I groups. So minus I groups are nothing but electron withdrawing groups. So they increases the acidic nature. So this is strong minus I. Okay, so it is having more acidic nature. So in which option we have? Yes, only the option 4 we have the maximum acidic character for nitro group containing carboxylic acid. So this will be the most appropriate. After this, we know fluorine is more electronegative than chlorine. Therefore, this is stronger electron withdrawing group than this. That's why it is having here and here and this one. I hope this is clear. And the next we have here is in the following compounds increasing order of reactivity towards nucleophilic addition. So here nucleophilic addition reaction increases for electron withdrawing group containing carbonyl compounds. So electron withdrawing group, if the carbonyl compound contain electron withdrawing group, its nucleophilic addition reaction reactivity increases. So now here you can see para nitrobenzaldehyde, yes, that is more reactive. So why it is more reactive? Nitro group is electron withdrawing group, so increases the rate of nucleophilic addition. So nitro benzaldehyde, that is correct. After this we have acetophenone. Acetophenone is a ketone, right? So ketones are less reactive than this aldehydes. These are aldehydes. So I can go with ketone is less, in which case acetophenone it is. So it is less in this case. So we can go with this and this. Okay, these two options are there. Next, benzaldehyde and para-tolualdehyde. So what is this para-tolualdehyde? So at the para position we have toluene, right? So it is electron releasing group. Okay, so I can say benzaldehyde is more reactive than this para-tolualdehyde. So I can go with option number 3. So that is the most suitable answer for this question. The basic fundamental thing you can consider, electron withdrawing group contains on the, if electron withdrawing group contains on the carbonyl compound, that increases the nucleophilic addition reaction. Why it increases? Because electron withdrawing groups withdraw the electrons from the carbonyl group and creates more electron deficiency. Therefore, nucleophilic attack easily takes place. That's it. Okay. Now, in the Gattermann-Koch reaction, what we will be using? HCl plus CO we will be using in presence of AlCl3. So this creates CO plus as the electrophile. So we have CO plus as the electrophile in this case. So you can go with option 1. Okay, the electrophile involved in the Gattermann-Koch reaction is this one. Okay, so where do we see this? So benzene with this gives benzaldehyde. Okay, with this reagent gives benzaldehyde. So this is the Gattermann-Koch reaction. Okay, in Koch you can remember carbonyl involves. Koch carbonyl involves. That's it. Gattermann-Koch carbonyl involves. Cannizzaro reaction. So what happens in Cannizzaro reactions? So carbonyl compounds should not contain alpha hydrogens. It means without alpha hydrogen, the carbonyl compounds with concentrated base undergoes disproportionation reaction. It means it forms one self oxidation product and a self reduction product. Okay, so it undergoes self oxidation reduction on heating with concentrated alkali, right? So oxidation product is carboxylic acid, reduction product is alcohol. So formaldehyde they are saying, now let us take formaldehyde here. So 2 moles you can take, treat with concentrated base. So what is the product formed? Formic acid, oxidized product plus ethyl alcohol. That's it. These are the products we can get here. Okay. So it has alpha hydrogen? No. So formaldehyde undergoes Cannizzaro reaction. So does it has alpha hydrogen? No. These are not alpha hydrogen. Okay. It does not contain alpha hydrogen. Alpha hydrogens means if this is a carbonyl group, the adjacent carbon is there, na? So this carbon is called alpha carbon. If any hydrogens present on it, those are called as alpha hydrogens. Okay. So this is what the alpha hydrogen, but this kind of group is not present on formaldehyde. So does not contain alpha hydrogen. It undergoes self oxidation and reduction. So what are the options correct here? B, D. So do we have any option B, D? Yes. first option. That's it. Hope it is clear without any confusion. Next. These are ethox, like ethers are given treating with HI. So this is tertiary carbon now. So upon treating with this, it will becomes plus on oxygen and goes out as this. So this is a carbocation. So now out of this, so again iodide will attack on this carbon and forms tertiary carbocation is formed, on that iodide ion is attached. So we will be getting, so what is the mechanism followed? What is the intermediate I told you? Tertiary carbocation. So it means it follows SN1 reaction mechanism. This is correct. Okay. And in step 2, what I told you, in step 2, the reaction in the step 2 of the reaction, departure of leaving group creates a less stable carbocation. No, it creates a more stable carbocation. Tertiary carbocation, tertiary butyl, this one, tertiary butyl carbocation, which is highly stable, right? So this is created here, which is a more stable one. So C, B are correct, not A. Okay, C, B are correct. So where do we have C, B? C, B. So option number 2. That's it. Aniline does not involve in Friedel-Crafts alkylation. Why? Because it forms Lewis acid base complex. So aniline, if I take, in AlCl3, see, this is a Lewis acid, this is a base, so it will form a Lewis acid base adduct, Cl3, like this. Okay, so here this is a complex it is forming by donating the electrons to it. So it forms a salt with a Lewis acid catalyst. Yes, that is correct only. And nitrogen acquires negative charge. No, it acquires positive charge actually, if we want to speak properly. Nitrogen acquires positive charge. Yes. Nitrogen acts as a strong ring deactivating in further reaction. Yes, this is also correct, because it is when it is acquiring positive charge, now it has no non-bonding electrons to give into the ring to activate the ring. Therefore, nitrogen with positive charge is a strong electron withdrawing group, right? So it means it deactivate the reaction. So I can say A is correct, C is correct, D is correct. A, C, D. Yes, we have option number 3. See, I felt like CUET paper is relatively easier than JEE mains and NEET and even EAP set paper also. Okay, so CUET paper is relatively easier than all these 3 papers. Okay, so I suggest, if you are really interested to do like any BSc degree, okay, so you can go through any of these universities. You will be having a better life than these normal local colleges. Okay, so I suggest you to take the CUET exam if you are really concentrated towards or focusing towards your BSc degree only. If you want to pursue only BSc degree, you can choose this best central university by attempting this exam. Okay, I hope you got what I am saying here. Next thing is, although chlorine is an electron withdrawing group, okay, electron withdrawing group, yet it is orthopara directing in electrophilic aromatic substitution. Yes, because chlorine withdraw electrons through inductive effect. Yes, because of its electronegativity, that is correct. Once again read the statement. Although chlorine is electron withdrawing group, okay, because of inductive effect, that is fine. Yet it is orthopara directing in electrophilic substitution reaction. Okay, chlorine destabilizes the intermediate carbocation formed during the electrophilic substitution. Okay, chlorine accepts the electrons through resonance. No, chlorine releases the electrons through resonance. So D is correct. Okay, so D is there in this option, this option, this option. And chlorine withdraws electrons through inductive effect. Yes, that is also correct. A is also correct. Okay, A, D is correct. Along with that, let us cross verify B and C. Chlorine accept, no, C is not at all correct. So C is there in this. Okay, so B is there here. So I can go with first option. Okay, I hope it is clear. Okay, then next, why C is not correct? Chlorine will release the electrons through resonance, but they are saying it is accepts the electrons through resonance, which is exactly opposite to the option D. So it is incorrect. Next, etard oxidation means, so whenever we have a methyl group or any alkyl group here, the methyl group will be treated with chromyl chloride, O2 Cl2, okay. So this will be producing benzaldehyde like this, conversion is CHO. So this is a benzaldehyde. So this happens in the etard oxidation, one of the important reaction. So now this is what? Benzaldehyde, which is aromatic aldehyde. So you can choose option 1, that's it. See, amino acids linked in a specific sequence, okay. So gives primary structure of protein. What it will gives? Primary structure of protein. Next, regular folding of specific hydrogen, specific sequence of amino acids due to hydrogen bonding gives secondary protein, okay. Then next, fibrous proteins are quaternary structure of proteins. The next, spatial arrangement of 2 or more polypeptide chains gives tertiary structure, okay. So 1 A, B, 2, 3, 4, yes. So you can go with the option number 1, okay. Next question here. Again important. So what is a Lucas reagent? This is concentrated HCl in presence of ZnCl2, anhydrous ZnCl2. So C2. And Toulon's reagent is ammonical silver nitrate solutions, and Jones reagent is chromium trioxide with acidic medium sulfuric acid, right. Rothschild salt is Felling's solution. So this is the order. So B4 only one option, 2 options, and A3 only first option is correct, that's it. I hope everything is clear here. C2 D1, yes. Next, again this is from haloalkanes chapter. So what is this Schwartz reaction? Schwartz reaction is for preparation of what? For fluorines, right, alkyl fluorines, okay. Finkelstein is for alkyl iodides. So Finkelstein is for alkyl iodides. B4, A3, Sandemeyer reaction, conversion of diazonium chloride to alkyl halides, right. So C1, D, alkyl Woods reaction, alkyl halides with sodium dry ether gives alkanes, okay. Clear, very standard reactions, very important neighbor reactions, very basic important neighbor reactions, okay. So now look, A3 only one option you can directly choose, there is nothing to cross verify here again, okay. And the next B4, that's it, fine. Next, what about this? What about this? Here estroidal, this will be what? Menstrual cycle, okay. So function or disease with a biomolecule you can choose, okay. So C2, okay. Then next, this is a very like static kind of concepts now, so directly you can choose. So again choose D1, which, where do we have D1? So D1, and the next C2, C3, what is it? Okay, C3. So D1 is there. The next C4. So it means Addison's disease, na? Okay, wait. Okay. The next beriberi. So A3 is there in this option. So you can go with option number 3. Okay. So like that you can, whatever the concept, whatever the topics you know, based on that also you can eliminate this kind of options. Okay. So nothing to worry about unknown things during the exam. Okay. So now look at here. So we have option, these are the reactants, products. So upon treating with water in acidic medium, so treat this with water in acidic medium. So how can we treat this? So this on this double bond add H plus. So here we are creating positive charge, add OH. So here it will be OH, here it will be H. That's it. So A2, right? So now B, again add H2O in acidic medium, add H plus here, tertiary carbocation OH here. So B1, okay. C 4. Again here if we do, it will give 3. That's it. Okay, simple questions. So this kind of conceptual questions you should learn. Okay, so once if you learn the concept, so whatever the question from wherever they are giving, you can easily answer. Okay, so this kind of static questions, I mean something like memory based questions, you need to study those from the NCERT books. Okay, actually there are some diseases or these biomolecules which are coming from the bio part, not exactly from the chemistry book also. Okay, so anyways you have to learn that, or you can eliminate based on your way of understanding the question. Okay, next come here. So what is the option? So A2, then next B1, that's it, done. C4, D3, that's it. We got everything. Option number 3 is correct. Okay, and the next, what about this? Not an analgesic. So what is that? Which are the following is not analgesic? Okay, so here morphine, codeine, heroin, these are what? Narcotic drugs, narcotic analgesics. But when it comes to ranitidine, it is a drug related to acidity refluxes, right? Something like acid, ulcers, stomach ulcers. Okay, so this is not a analgesic, so you can choose this option. That's it. Okay, very standard question. Again they are asking acidity of carboxylic acid, increasing order of the following, the increasing order of acidity of the following compounds based on their pKa value. So what is the pKa value? pKa inversely proportional to acidity or Ka, inversely proportional to acidity or Ka. So one which is more acidic, more Ka and less pKa. So which is more acidic here? C is more acidic. Okay, and the next chlorine is there, because fluorine is more electronegative, therefore more acidic. Same question again, within the paper 2 questions are of similar, right? So they are also mentioned this one in the question, again they same options here, C and B. Okay, then next B, next A, least is D. Okay, so now arrange them in the reverse order. So this is acidity order. Okay, so in the reverse means how can I make? So it should be D is more. Okay, so again, so D is more means okay. So now what we will be doing is, so remove formic acid aside. Why I am removing a formic acid aside? Because this is formic acid, this is chloroacetic acid, fluoroacetic acid, bromoacetic acid. Just compare these 3 and insert this in between. Okay, because this is having one carbon less, which is alkyl group is lesser than this. So depending upon the concept only we will be doing, without knowing their values also. Okay, so C is more acidic, so low pKa. So I can say low pKa for C, then B is more, then A is more than that. So check the options where we have in this order. A is more, then B, A is more, then B, then C. Okay, this is fine. Okay, any other options? B is more is there? No. C is more is there? No. No. Okay, so we have only one option. See the concept, even if we don't know the exact order of formic acid and alpha haloacetic acid or one fluoro acetic acid, so we can do just by understanding from the other options. Okay, from that, so from that what I can say? So I can say A is having maximum acidic nature, maximum pKa value and minimum acidic nature. That's why I have brought here A. Then next here they have included B, D, and then next B and C is least, which is more acidic it means. Okay, I hope this is clear, right? Based on this order only I have arranged them. Next, for SN2 reaction, the increasing order of reactivity of the following alkyl halides. So which is more reactive? SN2. So we know SN2 reactivity increases, SN2 rate of reaction increases with decreasing in branching. Smaller the size, easier the reaction, or smaller the groups attached, easy or the more is the reaction rate. So it is a primary bromine, more reactive. This is secondary, this is tertiary, again this is primary. So this is primary and this is straight chain, but this is a branching is there. So straight chain will be more reactive, so A is more reactive. So A is more reactive, only in option 4 is there, you can directly go with that. That's it. and C is least reactive. Okay, C is least reactive. So option 4 is correct. Okay, next we have battery or cell converts chemical reaction. Okay, read the following passage and answer the 5 questions. Okay, so after reading this, so we have at anode this is a reaction, and at cathode this is a reaction, and they are saying 67.2 liters of H2STP reacts in 15 minutes. Okay, the number of moles of hydrogen is oxidized. Okay, so at anode hydrogen is getting oxidized. Hydrogen is getting oxidized to H plus. Okay, it means oxidation process only now. So 67.2 at STP means divide it with 22.4 liters. Why I am dividing with 22.4 liter? 1 mole of any gas at STP occupies 22.4 liters, right? So we can get 3 moles of H2. So during the process 3 moles of H2 reacts in 15 minutes, you can understand. Okay, so number of moles of hydrogen is oxidized is how many? 3 moles. Directly go with option number 3. Okay, number of moles of electrons produced during the oxidation. Okay, so 3 moles of H2 means, okay, so 1 mole of each H2, like how many electrons it contains? 2 electrons it contains now. So these are becoming, so 3 into 2H plus, it means 3 into each one is giving, each molecule is giving 2 electrons. So how many mole electrons are involved? 6, 2 3 is 6 mole of electrons are involved in the process. So 6 moles. I hope this is also clear, which is very basic way of understanding. Okay, the next one here we have is quantity of electricity is produced in the oxidation of so when it is involving 3 moles, so we know 3 moles means 6 electrons are involved. So we know number of equivalents equals to number of Faradays equals to number of equivalents, right? So now quantity of charge they are saying. So total charge equals to N into F. So what is N here? 6 moles of electrons are involved. 6 into how many Faraday means 96400. 96400 we can write. Okay, so now, so do we have any option in this manner? So we can write this as Faraday, you can write 96,500 Coulomb, you can write. So now from this 0 0 we can get 636, 9 here, 3 again 54, 57. So do we have any option? Yes, we have an option here 57, 9 000 coulombs, right? So this is our answer. I hope this is also clear. So how I did total charge Q equals to number of electrons into Faradays. Charge into charge into number of electrons involved. So 96,500 coulombs into 6 gives this our answer. Okay, if entire current is passed through, entire produced is used to electrodeposition of silver from silver solution. Amount of silver deposited. So how many Faradays we have used? 6 Faradays are used now. So it means 6 equivalents, 6 gram equivalent numbers are dissociated, or 6 I can say 6 n into n factor gram equivalent means. So what is the n factor? Ag plus is converting into Ag. It means what is the n factor here? 1. Okay, how many moles it is? 6 Faradays for n factor is 1. So n will be 6 moles. So how many moles it is involved? 6 moles. So 6 moles means what I can say? So one atom is having atomic weight of 108 grams. So molecular weight, atomic weight is 108. 6 into number of moles are 6 moles. It means 6 into 108. So this will be giving 648. Okay, 648 grams is the answer. Okay, so option number 2 is correct. 6 into 108 gives this answer. Okay, it is also clear, right? Camphor in nitrogen gas. Camphor in nitrogen gas means what? So camphor, solid in nitrogen gas, solid in gas. So solid in gas, that's it, option number 2. Okay, so now this is again interesting question from organic. Identify the correct order of organic compounds in the following chemical reaction. Okay, See, they have taken some X treated with magnesium in dry ether. So definitely we know here this will be a Grignard reagent. Okay. Next, treated with water. So definitely there will be alkane is formed here. What is that? Alkane is formed. Okay. Now again this is treated with chlorine. They will definitely get a chloro, I mean some kind of product where it is having chlorine. Final product will be having what? Chlorine, because they did chlorination only, na? Let's see from the options. Correct order of organic compounds. 4 organic compounds are given. What is their order here? Okay. Finally we know chlorination is taking place, so definitely C will be the last one. Okay, C will be the last one. See, nothing to do here, directly we have only one option. Option number 1 you can see. So C is the last product. Chlorine is containing product, will be the substance is the product, final product. So this is the direct answer we can say, or if you want I will explain from each of the step. Okay. So take methyl bromide here, treat with magnesium. So this question mark is methyl magnesium bromide. Upon treating with water, so CH3 minus H plus from water forms methane. So what is the product here? What is our alkane? So this is our D, methane is the product here. Okay, this upon treating with chlorination gives chloromethane, that's it, methyl chlorine. So this is a C. So option 1 is the most appropriate order of this reaction. Okay. Next, tell me, arrange the following statements regarding osmotic pressure. So pi, molar mass of protein is determined by osmotic pressure. Yes, correct only. For osmometry is a technique used to find the molecular mass or molar mass of proteins. Osmotic pressure is proportional to molarity. So pi equals to ICMST we are writing now. So Cm means molar concentration, that is also correct. Okay. Reverse osmosis occurs when pressure larger than the osmotic pressure is applied to the concentrated side. Okay. And edema occurs due to retention of water in the tissue cells as a result of osmosis. Yes. Okay. So A, B, C, D. So all of them are correct. So option number 3. Okay. Last few more questions are also there. Vapor pressure of pure liquid AB are given, and also mole fraction. Okay. Total pressure is given and asking us to find mole percentage. So this is on Raoult's law. P total equals to Px plus Pa plus Pd. These are the two things they given. So again Pa I can write it as P naught A chi A plus P naught D chi D. So chi represents mole fraction. Okay, this is about total. So what is the total pressure they mentioned? So they mentioned here P total is 700. Take here 700. Okay, P naught A is how much? 500. So 500. Okay, they are asking about mole fraction of D na, mole percentage of D na. So let us say chi A I am writing it as 1 minus. So chi A plus chi B will be 1. So out of this chi B, I mean chi D, if we take 1 minus chi A we can write. Okay, so 1 minus chi A, 1 minus chi A is a mole fraction of chi B. I can write in this manner also. Okay, wait. They are asking about chi D now. So it means I can replace chi A as 1 minus chi D. Okay, so it means here I can write chi D. Okay, plus P naught D chi D. Done. Up to here it is clear, I hope. Next, what I can do? So 500 into 1 minus chi D plus P naught D is how much? Is 800 into chi D. Okay, now multiply this inside. 500 minus 500 chi D plus 800 chi D. Okay, I hope it is also clear. Very basic formula substitution question only. Okay, so now 500, 800 remains 300. So I can write 700 minus 500 equals to, so 300 chi D. Okay, this is the remaining thing. So from this, what we have 200, this side is 300 into chi D. So 2 zeros cancel. So we have 2 by 3, which is equals to mole fraction of chi D. Okay, so I can say this is 0.66. So how many? What is the mole fraction of D? We have 0.66. So in the percentage I can say 66.67 percentage. So we have 66.67 percentage here. For what? Chi D, mole percentage of D, mole percentage of A. If they ask, this is the answer. Okay. So but they are asking in the question about this, so you can choose option 2 as your answer. This is again on chemical kinetics question. How do we answer this? Volume is increased. Volume is increased for this reaction. Volume is increased by decreasing the pressure on it. If the reaction is following first first order with respect to X and second order with respect to A. Okay, then what happens here? So I can say rate is directly proportional to concentration of A. What is the order with respect to A? Second order. So write R2. Okay, and reaction is what they are saying here. Reaction is X. Reaction is first order with respect to X. Write like this. Okay. Now what happens? Let us consider this is the first equation. Okay. So now what they are saying? Volume is reduced. How much? Volume is increased. Volume is increased by decreasing the pressure. So if volume is increasing, see, concentration is nothing but number of moles by volume. So now volume is inversely proportional to rate, right? So volume, if volume increases, rate decreases, right? So volume is doubled. So increase it to double its double its volume. So it means it is becoming 2V. Okay. So 2V square. Here it is X, this is A2, NA2, this is NX by this is becoming 2V by 1. Okay. So rate, if you compare this, if we take, so here I am taking 2 square means 4, outside I am writing 4, in the bracket I am writing NA2 by V, and here it is 1 by 2 power NX by 2. It means this 2 I have written outside like this. So 2 4 ja 8. So rate, so second reaction what happening? It is decreasing by the 8 terms when we compare with the factor of 8 when we compare with the R1. Okay. So R2 is decreasing by 8 times in it from its initial value. So this is what the answer. So you can choose directly first option. I hope this is also clear. So make 2 equations from the given statements and compare them, you will get the final answer. Okay. Again P4O10 means how can we write? P4 means write phosphorus, 4 phosphorus like this. Done. Now we know valency of phosphorus is 4. So I am writing these oxygens like this. Like this. Now one more oxygen like this. How many phosphorus and oxygens are over? So 4 phosphorus is done. Oxygens are 4 over 8 over. So remaining 2 are there now. So till here 8 over. So remaining 2 I am writing 1 here, 1 here. So now number of sigma bonds. Count number of sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So do we have any option like that? No. So total number of sigma bonds present. Okay. Once again look into this. 4 outside. Okay, 5, 4, 5, 6, 7, 8, 9, 10. So 10, 14 is not there. So I think we are okay. So now once again we will check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, we have option number 3. 16 is the answer. How do we write this? Once again look here. So write the POP like structure first. P4O10. So first of all place the 4 phosphorus atoms like this. Okay. Now place the oxygens like, see, I am giving 4 oxygens like this first. Okay. Okay. So actually first you need to write in this manner first actually. First write in the POP bonds like this. Okay, like this. After this we still have 6 more oxygens. So place one oxygen here like this. Okay. So if the formula is P4O8, this is the structure. but here it is P4O10 na, so place 2 more oxygens between this, that's it. This is the structure, everything is balanced. Check now. I hope you got how to write P4O10, P4O8, P4O6 structures. Okay. Now in the exams, last year they have asked about number of sigma bonds, and this year we may expect that number of POP bonds. So how many number of POP bonds are there? 1, 2, 3, 4, 5, 6. 6 POP bonds are there. Like this you need to answer. Okay. Now one more thing here. They are asking about sigma bonds. Now you count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's why 16 is the correct one. So option number 3. I hope this is also clear. Okay. So now during the electrolysis of alumina to obtain aluminium metal, cryolite is added. So why it is added? To lower its melting point. To lower its melting point of alumina. Okay. Now here second inverse, what is a it is a unit of what? It is a unit of first order reaction. That's why. So rate constant, by looking at the unit of rate constant, we can determine which order of reaction it is. So you can have a generalized relation like this, concentration power 1 minus n time inverse. Okay. For first order, if n, like n represent nth order, like what is the order of that reaction? So when I am saying first order, 1 minus 1 0, something power 0 will be 1. So 1 into time inverse is nothing but second inverse. So that's why it is 1, n equals to 1, that is first order reaction. Okay, I hope it is also clear. Next, last question of this session. For a complex reaction, the order of reaction is equals to, what is it? The order of reaction equals to the molecularity. See, order of a reaction depends upon the rate determining step. Okay, how fast or how slow a reaction is determined on this rate determining step. In this rate determining step, the number of molecules, the molecularity of rate determining step is used to find the order of that reaction. Okay, so for a complex reaction, order of reaction is equals to the molecularity of the slowest step of the reaction. Okay, that is correct. I hope it is also clear, everything is clear. Again remember, order of an elementary reaction is directly given by the stoichiometric coefficients of that elementary reactants. Okay. Now for a reaction, generally the order of reaction is determined only by experiment, not theoretical. Okay, order of reaction always given by experiment, not the theoretical way. I hope it is also clear, and I think the session is really went well. And if you have anything to be discussed, you can write in the comment box. I will be waiting for your questions. Okay, so thank you for watching. Happy learning. No one watched, 0 watch minutes.